This is one of those factorable deals where you have to kind of do two steps. You're going to do a diamond problem. 4 times 3 is 12. You got a negative 8 down here. Two numbers that multiply together to get 12 and add to get negative 8. They both have to be negative if they're going to multiply to be positive and add together to get negative. Negative 6, negative 2. Add to get negative 8, multiply to get positive 12. But we can't say that these are factors. Those are simply replacements for the negative 8. We're going to put them into that equation. We've got a 4x squared. We're going to say it's a minus 6x and then a minus 2x. That's what those are for. Put them in place of the negative 8. Then plus 3. So we took the equation and removed that in its place with both of those. That's the point of the diamond. So now we can group these guys into twos here. I can take out a 2x, left with an x minus 3. I can take out really nothing. No, I lied there. That's not an x, that's a 2x. And you know how I saw that? I saw that because I saw what I had left. It's a good technique. I'd like to say that's why I did that, but I just screwed up. So I saw that if a 2x plus 3 is what's left, I need to have a 2x plus 3 or something like that over here. And when I realize there's a minus in the middle and I see the minus there, that just means I can take out a negative 1. When I take that out, I'm left with a 2x minus 3. There's the thing I was looking for. A 2x minus 3, and then a 2x plus 1. All of that is equal to 0 to find my roots, which means if I add 3 to both sides and divide by 2, I have a root at 3 over 2. And if I subtract 1 and then divide by 2, I get a negative 1 over 2. My vertex, well, that's a whole different story. That's a whole different problem than 1. Well, there are a couple ways of doing it. I think I'm just going to complete the square because this is an important concept for tomorrow's worksheet. So I've got a y minus 3. If I subtract 3 from both sides, move it over there, I got a y minus 3. I have an 4x squared minus 8x. I can take out a 4x, but I only want to take out a 4. When I take out that 4, I'm left with an x squared minus 2x. There is something I need to complete the square. What can I add? Well, I'm going to add half of 2 squared. I'm going to take b over 2 and I'm going to square it. This is a blast from the past, but we've done it enough. Hopefully it's still fresh. The b is 2. 2 divided by 2 is 1. 1 squared is also 1. Now I'm adding 1, but did I really add 1? I ask my classes this all the time. And sometimes they say yes, and they're wrong. We're adding 1, we're adding 1 times 4. Anything that's added inside here, if there's something outside, needs to be included over here. So I'm adding a 1 times 4. This can be cleaned up. 4 times x minus 1. It's not only what times what is going to give you that, but it's divide that by 2 and you'll get this every time. That was a negative 3 plus 4, so this is a y plus 1. If we move that 1 to the other side, we're basically done. There's my 1 over here, so the equation is y equals really just that. I'm not going to rewrite it. So my vertex is at 1 comma negative 1. If I recognize that I'm changing the sign of that and keeping the sign of that, it's a y equals, so it's a vertical one. Just for the sake of argument, if I go over 1 and down 1 and put a dot, and then that 4 out in front means that's a stretch factor of 4. If I go up 4 and over 1 in both directions, I'm going to get that equation. And it crosses some weird places. Oh, and by the way, those weird places are here and here, I think. Oh, that's a minus. This should be a minus 1. See? Again, a good thing to go back and look. Those are both positive. Silly, silly Mr. DuPont. Okay, so that, and again, this is a good lesson in, I'm just going to forget it. Oops.